Now, the next important component that we have to study are nuclear reactors. And when we talk of nuclear reactors, basically we are talking of nuclear reactors which are producing energy using fission. So, if you look at a normal fission reactor, this is the core of the nuclear reactor, which has the fuel and as well as the moderator. We'll discuss what is fuel and what is moderator. Then you have something called as control rods, you have a reflector, you have a concrete structure which is all around it, you are using a coolant, and then in the second half water is supplied from the condenser and steam will be generated from here, which will go into the turbines. So in very basic terms, if you have to look at any kind of reactor, this is what happens in a reactor. Now you have different components that we have listed out here. So let's try to understand each of the components one by one. Now, first of all, the fuel. So fuel obviously would be the one which would be used as raw material for the generation of electricity. So uranium can be a fuel, different kinds of uranium can be fuel, plutonium can be fuel, thorium is something that we want to use as a fuel. So all these things, all these are the ones which can be used as a fuel. Then apart from that, you have something called as a moderator. Now just go back to the discussion of fission that we did. What we discussed there is that there are neutrons that would be generated in the chain reaction. Now these neutrons generally are moving in a very, very high speed. For a nuclear reaction to happen, for a fission reaction to happen, you need to control the speed of these neutrons. To make sure that the speed of these neutrons are what we wanted, we use something called as a moderator, which would be used to decrease the speed of these neutrons. Then apart from that, you have something called as control rods. Now control rods, what the use of control rod is that whenever you need to absorb extra neutrons from the reaction, let's say the normal nuclear reaction that we had just seen, if you consider this diagram, what we see is that there are 3 extra neutrons that have been released. Now these 3 extra neutrons can have a capacity to move very, very fast. So now you are using a moderator to decrease the speed of these fast neutrons. But apart from that, we have to take another measure, and that is something that we do in case of a control rod, that all the extra neutrons that are there, these would be absorbed by the control rods. So control rods will absorb all the extra neutrons that are not required for the reaction to happen, so that it should not happen that these extra neutrons are going and bombarding some other uranium atoms or uranium nucleus, and they are forming an uncontrolled reaction. So to make sure that the reaction is not uncontrolled, you have a moderator and you have a control rod. Then you have a concrete structure, as I said, to make sure that the gamma rays are not going out of the structure. Then you have something called as a coolant. Now what the role of the coolant is that all the heat that is being generated here, all the heat will be transferred from this area to this area with the help of the coolant. Coolant will be the one which will contain the heat and supply the heat to the second part of the reactor. Now all the heat that is coming here, you are having water that comes from here. So this water will be under influence of this heat, and this will produce steam. So the production of steam would happen due to this water that is being used. So because there is a huge amount of heat that is being transferred by the coolant from the primary reactor to the secondary part of the reactor. So this steam definitely will be used to rotate the turbine and then produce electricity. So if we look at the parts of nuclear reactor, first of all, the nuclear vessel, this part. The nuclear vessel holds the other reactor parts. It is installed near the base of the nuclear reactor building. The vessel has a steel wall or it can be concrete walls. At least 15 centimeter thick. Steel pipes are carried on into and out of the vessel to carry water and steam, which is basically the coolant. Then the core. Core is what has the fuel. In simple terms, you should know this. So the core contains the nuclear fuel, and so is the part of the reactor where fission occurs. The core is near the bottom of the reactor vessel. It consists mainly of nuclear fuel held in place between the upper and the lower support plates. Then you have control rods. So what we have discussed is control rods will absorb all the extra neutrons. So they are metal rods that contain such elements as boron or cadmium. Please note this point, it's a very important point. These elements absorb free neutrons, thus help in the control of a chain reaction. The control rods are inserted into the core or out of the core or withdrawn out of the core to slow down or speed up a chain reaction. So whenever the control rods are inside the core, then they would absorb all the extra neutrons, but whenever they have been taken outside the core, in that case what will happen, the number of neutrons will again start to increase. So that's why, depending on whether you need to slow down the process or you need to increase the process, depending on that you will either insert the control rod or you would withdraw the control rod. Then you have something called as a moderator. So moderator is a substance such as water or carbon, this is basically graphite, that slows down the neutrons, and sometimes also liquid sodium is used. Slows down the neutrons which passes through it. The reactors require a moderator because the neutrons released by fission are fast neutrons, but slow neutrons are needed to cause the chain reaction in the mixture of uranium-238 and uranium-235 that the reactors use as fuel. So uranium-235 is actually used as the fuel. And then finally you have something called as a coolant. So what the coolant does is, first of all, it will again be a substance like water or carbon dioxide that conducts heat but does not easily absorb free neutrons. So the coolant carries the heat from the chain reaction to the secondary part of the reactor. So this is basic function of a reactor. Now what we need to know are about the different kinds of reactors that you might hear about. So for example, pressurized water reactor. Pressurized heavy water reactor is used by India for the production of most of the nuclear fuel. Then apart from that, you have something called as a boiling water reactor. Then you have something called as a fast breeder reactor. So what do we mean by all these terms? So first of all, when we talk of pressurized water reactor, or another variant is pressurized heavy water reactor. In such a case, the fuel that you are using is going to be enriched uranium. So remember these parts. What is the fuel being used for a given type of reactor? What is the coolant that you are using? What is the moderator that you are using? These are the three main things that you should know about each of the nuclear reactors that we are going to discuss. So the fuel here is enriched uranium. The moderator and the coolant are either water or graphite. So in case of a pressurized heavy water reactor, instead of it being water, it will be heavy water. What is heavy water? When we talk of heavy water, what you know is that there are different isotopes of hydrogen, right? What we discussed, 1H1, 2H1 and 3H1. So this is the normal hydrogen. This is called as deuterium. And this is called as tritium. So under normal circumstances, what you know water as is H2O, right? Which is the normal water. But instead, if this isotope of hydrogen is used, then you get something called as D2O, which is called as heavy water. So in this type of nuclear reactor, we will use heavy water instead of normal water. So the moderator and coolant would be water or heavy water depending on which kind of nuclear reactor you are using. So the energy that is generated by the reactor core will be conveyed through the cooling water, which flows at high pressure into a heat exchanger. The reactor is based on the principle that water under high pressure can evaporate without reaching the boiling point at a temperature that is greater than 100 degrees Celsius. So actually it reaches temperatures up to 300 degrees Celsius. In the exchanger, the vapor cools and condenses and returns to the reactor in liquid state. The exchanger, there is a heat transfer to a secondary water unit. The water from the secondary circuit that comes from the heat produces steam, which is introduced into a turbine that drives the electric generator for the production of electricity. So this is basically a schematic structure of how a pressurized heavy water reactor looks like. So this is where you have all the fuel, you have the control rods here, you have a steel pressure vessel, then you have a pressurizer. The steam generation will happen in the second stage. Cool water will be provided from this side. Since you are providing a sufficient heat energy from here, this will lead to the conversion of water into steam, from where it will be fed into the turbines for the generation of electricity. So from here itself you can see that water is coming back and is being fed here. So that's why you are also using it as a moderator. So this is the concrete structure all across the reactor. Then the next is boiling water reactor. See, in India we have approximately 20 nuclear reactors, out of which 16 of them are pressurized heavy water reactors and 4 of them are boiling water reactors. So we have boiling water reactors in India also. Again, fuel is same as the pressurized heavy water reactor. Moderator and coolant are both water in this case. So the thermal energy that is generated by the chain reaction is used to boil the water. The steam produced is introduced into a turbine that drives the electric generation. So the process that you are using here also is more or less the same. Only difference is that now you are using boiling water, you are not using heavy water anymore. So the steam from turbine passes through the condenser, where it is transformed back into liquid water. Subsequently, the water returns to the reactor driven by a suitable pump. So if you look at this particular diagram, the water from here itself will be converted into steam. From here you have water again, and this water itself actually is also being reused as a moderator. So both your moderator as well as the coolant is a boiling water. Then you have another kind of reactor which are called as fast breeder reactor. So why fast and why breeder? These are the two things that you need to study here. So the main characteristic of a fast reactor is that they don't use moderator. There is no moderator that is being used here, and therefore most of the fission that is produced are by fast neutrons, and therefore the name fast comes because it is using fast neutrons. So you have different kinds of neutrons, fast neutrons, thermal neutrons, but we need not go into the details of that. Then the reactor core consists of fissile areas surrounded by a fissile area where natural uranium is transformed into plutonium. Also the cycle uranium-233, thorium can also be used. So as a fuel, you can either have natural uranium or enriched uranium, that is uranium-235, or from the cycle we can have uranium-233 and thorium, both being used as the source of fuel for us. The coolant that we have here is liquid sodium. The steam is produced in the heat exchangers. Now the next part, why breeder? One is fast, one is breeder. So the name breeder is due to the fact that the reactor produces more amount of fissile material than it consumes in operation. It means that it generates more fuel than it spends. That's why fast breeder reactors are so important. That now if we are able to get into the fast breeder reactor, the amount of byproducts that you have, that is more than the input fuel that you would have given. So you don't need an external fuel to be used as a fuel for your reactor. Whatever byproducts you are getting, from there only you will generate all the fuel that you need. So that is the most important part with respect to a breeder reactor or a fast breeder reactor. So dependent on these only, we have a very unique nuclear program that has been developed in India. So now what happened in India is that we have a huge amount of thorium presence. The amount of thorium that is present in India is just second highest in the world, highest being in Australia. Now the very famous scientist Dr. Homi Jahangir Bhabha, back in 1960s, early 1960s only, what he said that see, uranium cannot be used for long. Uranium is a kind of mineral source that is present in finite amounts in the earth. So after a point in time, this will not be available anymore, and even then India does not have a very high amount of uranium presence. Apart from that, you have another problem that we are not a part of nuclear non-proliferation. So in such a case, what happens is the foreign countries would not want to give you the nuclear fuel, because they might think that you may not use it for positive purposes, you may use it for negative purposes also. If we are using it for negative purposes, if that is the case, then the foreign countries would not want you to give the fuel. Now you don't have much of uranium, you cannot get the uranium from outside, then you need another nuclear fuel for your program. Now, thorium is also a radioactive element, but it is not fissile, meaning that it cannot undergo fission naturally, but it can be made fissile. So this is what we are trying to do in our nuclear program, that we are enabling ourselves to start using thorium. And for this very purpose, he had envisioned a 3-step nuclear program for India. That what we will do is, we'll start using pressurized heavy water reactors first. If you look at this diagram, that we will start using pressurized heavy water reactor. Now what will happen in a pressurized heavy water reactor is that natural uranium will be used as fuel. Now from here we will start producing electricity. 12 gigawatt of electricity over 30 years would be produced. From here, as byproducts, you will get uranium as well as plutonium. Now this uranium and plutonium will be used in the fast breeder reactors. Now here for the first time we will introduce thorium, so that now we will start making it fissile. We will start making it fissile. Now since these are fast breeder reactors, here also from here you will have a production of electricity, that is 300 gigawatt over 30 years of time. Now since these are fast breeder reactors, what happens is, the amount of plutonium that you had given here and the amount of plutonium that you have here, this amount of plutonium will be higher as compared to this amount of plutonium. So that's why this becomes a breeder reactor. That's why it is becoming a breeder reactor, because you are generating a large amount of plutonium, and as you can keep this part of reaction working. Now as a byproduct you get uranium-233, and this thorium has been made fissile now. Now the combination of uranium-233 and thorium can be used in the third part of reactor. This also will be a kind of breeder reactor where you will get more uranium-233, and since you are getting more uranium-233, the amount of power generation that you will keep doing would be 500 gigawatt power for 500 years. So this is happening only for 30 years, this is happening for 30 years, this can sustain for 500 years. So that's why this is such an important part of program for us. Such a sustainable part of energy, such a sustainable source of energy it can become for us. And that's why back in 1960s only, we started to think about this part, that there would be an area, we would come to an instance where we will have to start thinking of thorium as a fissile fuel, or thorium as a fuel for our reactors. And this kind of reactor is called as advanced heavy water reactor. So this will be our third stage. We have not yet entered the third stage. We are still in the first stage, but we have started getting results from the second stage also, but we have not been able to reach the third stage yet. We are going to reach it. So what the government has a program for 2030, that by 2030 we need to start producing 10% of the entire energy, 10% of the entire electricity using nuclear sources. Right now the amount that we are able to produce is just 2% of the entire electricity. This we want to increase it to 10% in coming future, that is by 2030, and that's why we are working on this entire principle, that in the first stage we will have pressurized heavy water reactor, from where you will generate some electricity for, that is 12 gigawatt of electricity for 30 years. From here you get plutonium as byproduct. Plutonium with uranium and thorium will be used in the fast breeder reactor in the second stage, where these fast breeder reactors will produce more plutonium than it is taking as its input. Since that is happening, you are self-sustained now in case of plutonium. Now uranium-233 that is being taken as the byproduct from the second reactor, that is fast breeder reactor. this will be used for the production of electricity, that is 300 gigawatt of electricity for 30 years. Now this uranium-233 with thorium will be used as a fuel for third generation, and this also is a kind of breeder reactor where you are producing more and more of uranium-233 along with thorium that is abundant in India. So that's why we can use this kind of energy for 500 years. It can sustain the energy requirements for India for 500 coming years. So that's why India has this unique energy program or nuclear energy program for the generation of electricity or power through nuclear energy. So what we have learnt in this unit is what is neutron, what is nuclear energy, what is radioactivity, what is fission, what is fusion, what is nuclear reaction, what are the different kinds of reactors, and finally, so that we could have come to this area, that is what is India's nuclear program. And what is nuclear program? We have discussed this part here. So these are the areas which are important for you from examinations perspective. Know all the important stuff, all the small concepts that we have learned here. Even the small things, for example, let's say if you talk about atomic number. Atomic number is the most unique feature for an element. So if we increase or decrease the atomic number, we change the element itself. And what is atomic number? The number of protons. What is number of protons? It is equal to number of electrons. So number of electrons or number of protons can be said to be atomic number, but by definition atomic number is number of protons, not number of neutrons, not number of electrons. So all these small concepts can be asked in the examination. So what we learnt about alpha, beta and gamma decay, the differences between the alpha, beta and gamma decays, all these kind of concepts also will become important for you with respect to this particular unit. This is where we'll end this unit. Thank you very much for joining.